Hi, it's Mr. Kane here, and today we're going to talk about the atom and the history of how we come to know about what's in it and its structure. We begin with a Greek philosopher called Democritus, and if you think that name sounds familiar, think of the word democracy and you've got the idea. So he lived quite a long time ago, and he was one of the first to suggest the idea of atoms, taking a pretty simple idea and just taking it a step further. So he thought that you couldn't make things any smaller. They were indivisible. You couldn't make it smaller and you couldn't destroy them. He was just thinking, as he was, like I say, a philosopher, so thinking about it, so no scientific method, so it took a much longer time before his ideas were accepted. So around about then, he got this idea. That's him there, or a picture of a statue of him, what we felt he looked like. And he just basically pounded things up or ground things up in his pestle and mortar, and he got them so small he couldn't get them any smaller, so he figured that must be as small as things get, and this is the Greek word for indivisible, so atoma, so that's where we get the word atom from. Then along come John Dalton much later, so it's still a long time ago but much more recently than Democritus, and he used some experimental scientific method to start to work with Democritus's ideas. And he looked at the way that elements combine, the ratios in which they combine. So here we have elements of X, elements of Y, and they make this compound XY. So 16 of them plus 8 of those go and become 8 of that molecule, that compound XY. And we've got the same ratios throughout, and it was the conservation of mass that Dalton worked with, because we've got the same mass on, let's see, on this side here we've got the same mass as what we have over here, the same amount of stuff at the start and at the beginning, but he was looking at the ratios, so 16 and 8. That's what he was interested in, the ratios of how things join together. So carrying on with our history story, 1808, John Dalton, he thought that it was all made up of tiny spheres, our atoms, they could bounce around, and he called them atoms. So taking Democritus's idea a little bit further and a bit of scientific experimental method behind it. Let's go further, 1897, J.J. Thomson, famous name from the Cavendish laboratories in England, and he found that atoms would sometimes spit out a much smaller particle. He called it the electron. So now we're getting away from atoms being completely indivisible and start to look at some of the bits that actually make up an atom. And he used this thing called a cathode ray tube, and they'd been around for quite a while before he started using them, but he was sort of using them to define the idea of the electron. And this cathode ray tube, you're probably more familiar with it than you realise. So it looks a bit like this. This is a very simplified version. So we've got on one side, we've got over here, we've got electricity being pumped into it, and that creates a beam of electrons going through here, and we've got charged plates, top and bottom, and a big magnet here. The magnet's used to steer the beam, and the beam can go this way and hit onto the screen. Now the screen fluoresces, it glows in the dark. So as the electrons hit it, they created an image, or created a spot, so they could see where these things were hitting depending on the charge they put through the plates and how the magnet steered it. Now if we take that cartoon picture and turn it into reality, that's what it looks like. So we have on the end of it over here, we have plugged in the high voltage electricity. Here is the magnets and electrical charged plates steering it, and at the front over here we're going to have the fluorescent screen that the electrons hit on, or the cathode rays, which we now know electrons hit on, to leave a mark. It glows in the dark. Now put a fancy plastic case around it and a heap of other stuff in there that translates things, and we end up with that. So the cathode ray tube became what we know as the television, and it was sent out, and the cathode rays would dance across the screen. Coordinated lines would create the images on the screen. And we've taken that now a step further, and we have now our flat screen TVs, which have gone away completely from the cathode ray tube and use completely new technology. But the foundations was the cathode ray tube, beginning with the learning about what was inside an atom. So let's carry on with the atom story. Back to the history of it. So 1904, Thomson had this idea that the atom had electrons scattered all through it, so they're a negative charge, so there must be a positive charge to balance that out, and he thought it was like plums surrounded by a pudding, so it's called the plum pudding idea, or if you think of raisins in a fruit cake. Okay, so here's our model. The positive charge and the electrons are sort of scattered randomly throughout that to create the atom. Then we've got protons. They were actually found before we found electrons. Okay, Goldstein, German scientist, saw these in 1886, that in the cathode ray tube, which so it's been around for a while, there are rays going in the other direction. So even before we knew the rays going in one direction were electrons, him and some of his students figured out that they were protons, or positively charged particles going the other direction, which we now know are protons. And we also know that they are lots bigger than an electron. Still really, really tiny, but lots bigger. And then comes the neutrons. So in 1932, this guy Chadwick figured out that there was one other particle in the atom, the neutron, and they have no charge, but are the same sort of size to the proton. And his work paved the way for the nuclear age that we have upon us, and he was one of the lead scientists to work on what we now know as the Manhattan Project, which gave rise to the first atomic bombs. So, subatomic particles. So we now know that atoms are made of smaller bits, three of them, three kinds of subatomic particles. We have electrons, we have protons, and we have neutrons. And we also know that they have charges and size. The proton has a positive charge and has a really small mass, so small it doesn't really sort of figure on any modern day scale like grams and kilograms. So we gave it its own unit. It's called an atomic unit, and we gave it the number 1. And the neutron's got no charge, and it also has a mass, an atomic mass of 1, the same size as the proton. And the electron has a negative charge, and it's so much tinier that we basically say it has no mass. So the mass of the electron is all made up from protons and neutrons, and the electrons make up such a small amount of that it doesn't really register on any sort of scales that we use. So we say it's got no mass, but it does, but it doesn't. So that's sort of how we come about the atom, and we learn about the bits inside the atom. So hope that was helpful, and